We're going to start talking about something called point-slope form today, but before we do that, I want to review slope-intercept with you very quickly. Remember, in slope-intercept, it's y equals mx plus b, where m is our slope and b is our y-intercept. Here I can see my y-intercept is in fact 4, so I can cancel out b and I can cancel out c because a and D are the only one with a B value of 4. I can see also that this line is in fact negative. So I know my slope is going to be negative, which means it cannot be A, but I am going to double check that it is in fact negative 2 over 3. I have another very nice point. This is called the x-intercept, where we cross the x-axis. So I'm going to count down 4. So there's my negative. And I'm going to count to the right 6. And when I put in, remember, rise over run, so negative 4 over 6 is in fact negative 2/3, making my answer D. If you did not turn in your slope-intercept review paper from Friday, please turn that into the purple bin on my desk, as it will be a grade. So I need you to make sure you get that turned in. Your extra credit from Friday is not due until tomorrow, so you still have some time to work on that. On our notes today, we're going to talk about point-slope form versus slope-intercept form. Slope-intercept is what we are familiar with, so we're going to talk about this new one. If you know the slope of the line, the m, and the coordinates of one point, now that one point is not the y-intercept, right? There's always lots and lots of points on a line. Okay, so if we know a point that is not the y-intercept, just a random xy point, then we can write an equation in point-slope form. You do not have to memorize this. It is on your formula chart, but we're going to talk about how to use it today. So we're going to write an equation in point-slope form, y minus y1 equals m parentheses x minus x1 of a line that goes through negative 4, 1 and has a slope of 3/4. Something I need you to make sure you remember, just like when we do y equals mx plus b, the y and the x stay a y and an x. When we do point slope, this very first y and this very first x will stay y and x. We're only going to be plugging numbers in for y1, m, and x1. On our coordinate, that is just our xy coordinate. So kind of like we labeled x1, y1, x2, y2 when we did slope. So it's just a random xy coordinate. That's not the y-intercept. And we have a slope of 3/4. This is our m. So I'm going to go ahead and put my 3/4 here. That's my m. I know that. When you put an x and a y into point-slope form, notice that your x is last and your y is first. Sometimes people flip-flop that. So be very cautious. So if we say y minus y1, my y1 is 1, equals m 3/4, x minus my x1 is a negative 4. Now, you will not normally see this as a minus 4. You will often see a double negative we know becomes a positive. So we could also write this as y minus 1 equals 3/4 x plus 4. So both of these are going to be the same. So we're just going to start off by practicing writing and identifying the pieces. Here I have another one. 6, 1 is my x1, y1. And negative 5 over 2 is my m. So when I plug numbers in, y minus my y1 is 1 equals m negative 5 over 2, x minus my x1 is 6. Now, this should look kind of familiar because we have taken this and distributed to change to slope-intercept, which we will look at doing in a few moments again, just to review that. Write the point-slope form of the line with the given slope passing through it. So now I want you to try a little bit. x1, y1, and I'm slowly going to take away some pieces for you, right? So I've got it set up for you. Y minus y1 is a negative 1. I'm just going to make that a big plus sign because two negatives become a positive, equals m is 4. X minus my x1 is 2. And now we're done. We're just practicing plugging those pieces in. On number 2, And again, I would strongly suggest you label just because it helps us visualize. Y minus 2 is my y1. So notice I took the labels away from you. But if you wanted to write them, you could. But I want you to get into the habit of what does that mean? Equals m 7/8 x minus x1 is a -7, so we would make it a plus. Please make those double negatives a positive because you will not see it minus minus. Now I've taken all the lines away, but we can label, and you can see the pattern. Y minus y1 is 3 equals m parentheses x minus x1. So we've practiced plugging those in, so hopefully you're starting to feel a little more comfortable with that. But what if we did the opposite? So now I'm going to give you the equation, and I want you to take out the slope and the y and the x and the y. So I'm just going to label this for us y minus y1, x minus x1, just because it's new and we're practicing, so we can see very quickly our slope is 3/2. Now this is where I want you to be a little bit careful, because our formula is y minus y1, x minus x1. So notice that these minuses, this minus and this minus, are from our formula. This minus and this minus are from our formula. So my x1 isn't actually minus 3. It is just 3. My y1 isn't minus 2. It is just 2. So I want you to notice even up here on number 1, when we plugged those numbers in, it was a minus 1 was my y right here. Let me click the right button here. This was a minus 1, and when we put it in the equation, it became a plus 1. Our 2 was a positive 2, but when I put it in the equation with that minus in front of it, it became a minus 2. So notice when we plug those numbers into our equation, our signs change, and that's going to be a really big thing. So we can see that here as well. Y minus y1, x minus x1. So our slope, that's the easy one, minus 5. And again, we have a minus here, but now it's a plus. So that meant that my y1 was originally a minus 2, because remember, a minus minus becomes a plus. That also means that my x1 was originally a minus, right? A minus minus becomes a plus. So my slope is -5, and my x1 is 7, and my y1 is -2. Again, pay attention to the order. Sometimes people, they flip-flop, but the y is first, so we have to move it to the back. So what do we notice about the x and the y coordinates when you put them in the equation? The signs change or flip. Okay, and that's because we have that minus as part of our formula, just like when we plug it into our slope formula. So now let's do a little bit of what we've done before, and we're going to change this to y equals mx plus b. So we're going to distribute, and we've done these steps multiple times. -3/2x. -3/2 times -3, use your calculator, is -9/2. And then we're going to move our constant. Y equals 3/2x. -9/2 plus 2 is -2.5, or if you're leaving it a fraction, which is totally acceptable as well, -5/2. So I would take either of these. You could graph your slope-intercept, and you could look at your table to see if that point matched. If you pulled out the point, 3, 2, to double check if you would like. Here is another one. Distribute. -5x. Negative times a positive is a negative. Be very careful with your signs. And then we're going to move our 2 over. y equals negative 5x minus 37. Hopefully you're remembering that. You guys did really well the first time we worked through that. So on the back, I want to take what we just talked about with point slope, and I want to connect it with slope intercept. So if you know the slope of a line and the y-intercept, we can write y equals mx plus b. So we're just going to review that real quick. We did that last week, where write the equation in slope-intercept form, right? Slope, and again, this is on your formula chart, slope-intercept. If you don't remember, that's y equals mx plus b on the chart with a y-intercept. So here's your b of 4 and a slope of negative 5 over 2. So y equals m negative 5 over 2x plus b is 4. Here's another one. Now this one didn't give you a coordinate. It just wrote out the words. M and b are like this. So y equals 3 over 4x. And that's a positive 2 for my b. Hopefully you're feeling more comfortable with that. So now let's take a little bit. Write the slope intercept, y equals mx plus b, given the slope, okay, and the y-intercept. So this is you trying. So you should have written y equals 2x plus 2. You should have written here y equals 7 over 8x minus 2. And then on this last one, y equals negative 5x plus 1/2. You could also write that as a 0.5. So now here's our question. What do you notice about the x value of the y-intercept? So the x value here, here, and here. So you should notice that the x is 0 for the y-intercept. And that is why when we graph it, it is always on the y-axis because we're not going across any on the x. So here's our last piece to tie everything together. We're going to graph a point slope, and then we're going to check it with slope intercept. So I want you to make the connection between the two. So y minus y1 m x minus x1. So back to what we did on the front. So my slope is 4 over 3. So I know my line's going to go up. And my x1, remember our signs are different. So this is a minus 3, so it becomes a plus 3. A minus 5 becomes a plus 5. So we're going to graph, just like when we graph slope intercept, we start with the coordinate, the b value. We're going to start with this 3, 5. And then we're going to count our slope. Now, notice our slope is 4. 1, 2, 3, and I've run out of room. I can kind of guesstimate. 4, 1, 2, 3. But remember also we talked about a negative is a positive. So if I made both of these negatives, instead of going up and right, I can go down and left. We talked about that the other day. So if I go down 1, 2, 3, 4, 1, 2, 3, oh, there's my y-intercept right there. And I can draw my line. Okay, so if you don't have enough space to go up and right, you can always go down and left. Simplify the equation above to slope-intercept form, and then does the y-intercept on our new equation match our y-intercept in our graph? So if I'm going to take y minus 5 equals 4/3 x minus 3. So when we distribute y minus 5, 4/3 x, 4/3 times a negative 3 is a negative 4, plus my 5. You guys are really great at this. So we get y equals 4/3 x plus 1. So this is saying my b is 1. So if I come back up, and in fact, yes, on my graph when we just did this, my b was in fact 1. So does it match? Yes, it does. So remember, it doesn't matter if you start with the b value or if you start with the coordinate they give you. it is going to go ahead and be the same. So let's try one more of those. My slope is -2. I'm going to write -2/1. I know this is going to go down. And again, pay attention to your signs. X1 is a positive. When we plug it in, it's going to change to a negative. And the same thing on our Y. So we're going to start at -3, -2. So to the right 3 and down 2. And my slope down 2/1. And if I want to get to my y-intercept, I can keep that pattern going. I should get a -8 right there, but we'll check it and see. So when we distribute that -2, so I have y plus 2. I'm going to distribute this -2, -2x minus 6. I'm going to move my positive 2 by subtracting it. Y equals -2x minus 8. Does that match our y-intercept in our graph? Why, yes, it does, because they are the same. Make sure you glue these notes in your journal. Then you're going to work on this practice. Leave your notes out so you can see what we were working on. This is very similar to our notes. Have a great day.